Now, generally when you write a Java program, how actually it executes? Now, first of all, let's say you have written a abc.java code. When you give it to the program called javac, this is your Java compiler, where it compiles your code into a bytecode, abc.class. Now, this is the bytecode we are talking about as platform independent in our previous slide, which means that the same bytecode you can copy into other machine. That means when I say other machine, other operating system altogether, and can get executed. That means, let's say I have written this particular Java code abc.java on Windows. The same abc.java source code I can go and execute in a Unix machine, and the same bytecode which gets compiled after using this program, this also I can get executed in a Unix machine, provided the JVM of that operating system is available. That's why I said Java provides two levels of portability for you, one at source code level, another is at bytecode or object code level. So once this bytecode created, what exactly happens? This is how JVM looks internally. What it does is, once your bytecode comes in, the JVM loads that into class loader, where the job of that guy is to not only execute that class, but also look if there are any other class files do I need to load. After it is done, it will be sent to a bytecode verifier module, where that guy's job is to see whether this bytecode is a best fit to be sent to the interpreter. It is like validating whether this code is sent to the other module I have. That is what it does. After that, it will send to your JIT, which is called just-in-time compiler, where it will convert your bytecode to the native machine code. And the interpreter, after getting converted to the bytecode, it scans and then it's executed on the OS hardware you have. And we also discussed about this platform independent at bytecode level. That is what we have been focusing on, how it really happens. Like I said, in a programming language like C, myprogram.c, you have a software or a program in Unix machine called GCC, which means a GNU C compiler, where when you execute it, it actually produces a machine code. When I say machine code, the exe file which you are looking here, that can get executed only on the OS or hardware you created this particular executable. It cannot be executed anywhere. That's why it is platform dependent. Here, platform means both OS and hardware. Whereas in the case of Java, what really happens is, when you execute, or rather than execute, the right term should be when you compile using javac, it provides you an intermediate code. That means before even converting to machine, there is one more additional code gets created, which is the bytecode. And that bytecode you can copy and execute in any other operating system. Like let's say this is executed in a Windows operating system. The same code you can take and copy in a Unix operating system, where that must have a JVM of Unix, and that's it. It can get executed. That is how Java become platform independent in terms of bytecode level also. Now, in the Java modern compiler design, if you look at, it comes with three different types of things. Like, you have a JVM, you have Java runtime environment, then you have JDK. All will help you to program better and develop code faster, performance, lot of things. Now, what exactly is a JVM? So just focus on the term virtual. So here JVM means it's a virtual machine. That means it is not a physical machine that exists. And here, when you say virtual, it is more about talking about the physical CPU. Here we do not have any physical CPU in JVM. It is actually like a logical entity where it executes your code in that particular virtual processor. Now JavaFX in 11, if you look at, this was removed as part of JDK. Now JavaFX comes as a independent module. So if you want to install it, we have a separate step for it. But before that, if you want to check what is the Java version installed, you can always execute this Java ---- version command, and it will tell you what is the current version available in your computer. Now, like I said, since the JavaFX is coming as separate modules, and if you want to get all that into your code, you can set the path to fx something like this. And after that, you can always compile your code, and while you're compiling, you can give the JavaFX module path like this. And whatever modules related to JavaFX, you can always pass this. And this is your actual source program. That is how you can make use of the JavaFX independent library, which is very powerful. And you can use it even though it is removed from JDK by doing this step. Now, how you run it? Once you added it, like we have seen in the previous slide, All you can do is while running also you have to pass it because it is an independent package, and automatically all the JavaFX controls you want will be available in your code. Now, Java also comes with something called GMC, which is JDK machine control, and it has several things that helps you to do a good amount of data analysis on your code. So how it helps? So it helps you in making your code more performance optimistic. It helps you in making better uses of memory. It comes with a lot of monitoring tools, profiling, all that, so that it does good amount of job on your code to make your programs or applications run faster and use less memory, all that. So that is all taken care by this GMC. And we have seen what does just-in-time compiler do? It actually converts your loaded bytecode into machine code. That's what the main job it will do. And apart from that, it actually does a lot of optimization also so that it gets executed in a native machine efficiently. So like I was saying, apart from just converting to bytecode, it also do something like code optimization. Like for example, it will make something like inline function translation whenever it is required, some constant folding. Wherever you think the optimization is required, it actually does all the job so that when you convert into native, it will have less burden to get executed. So there are a lot of optimization possible.